Okay, let's not waste any time. So I'll do the questions you asked me on WhatsApp, which some of them are about financial mathematics, and then other ones are about Euclidean geometry. Okay, let me forward these ones for Euclidean geometry on the group because they were sent to me via private WhatsApp. So I'm forwarding them to the group just now. Okay, let's start with finance question and then we'll go to Euclidean geometry questions. So I believe you all have the question with you now. So the question we have here is question number 3 and question number 4, which question number 3 is talking about Siseko, who is hoping to buy a car when he turns 18. His grandmother offers to sell him car for 131,071 cents. He works on Saturday only and earns 200 every Saturday. He saves R1 on the first Saturday. Each Saturday thereafter, he doubles the amount he saved on the previous Saturday. Okay, this is the statement which is important to take note of, that each Saturday thereafter he doubles the amount he saved on the previous Saturday. He puts the money into a bottle on his desk and not on a bank account. So the first question in this case, it says, in which week will his weekly payment exceed his earning for the first time? And what is the amount of the final payment he can afford? Okay, let me summarize the question in this way, that this guy needs to buy a car, of which the car is offered to buy from his grandmother is costing 131,017. So this is the amount of the car. But we are told, let me see, car amounts. So we are told that this person is earning. So his earning is what? Is 200 rand. So from this 200 rand, he's saving. He saved 1 rand pay every Saturday. Every Saturday, he will be saving 1 rand. But we are told that this person, each Saturday thereafter, he doubles the amount. So in other words, the money he is saving for the first week is going to save 1 rand. And then for the second week, how much is he going to save? He's going to save 2 rand because it's double the previous amount. Eh? And then on week 3, how much is he going to save? He's going to save 4 rand. And then like that. After that week, he's going to save 8 rand, 16 rand, up to so far. That is the information we are given according to the question. Are we all together?
Yes.
Okay. And then now, the first question requires us to find in which week will his weekly payment exceed his earning, of which his earning is 200. So we want to identify the week in which his earning will exceed 200. So now this is how we're supposed to solve this question. You need to identify the kind of series we are dealing with here. It's a series, not a sequence. So from this series, you can be able to identify that the series you are given there is a geometric series because we have a common ratio. We don't have a common difference, like what I've done before. On that one, I was giving an answer as if we are dealing with arithmetic series. Here we are dealing with geometry, of which geometric is given by two formulas. There are two formulas you can use for geometric sequence, especially if you are given a finite series. So there is another formula for infinite series, but here let's deal with finite series, which have the last term. So there are two formulas for finite series. The first one is this one of Sn, which stands for the sum a into r to the power of n minus 1, all divided by r minus 1. This formula you only use when r is greater than 1. And then there's another one of Sn, which is equal to a into 1 minus r to the power of n, all divided by 1 minus r. That formula, you use it when r is less than 1. But both formula, r must not be equal to 1 in the two formulas. So can you tell me which formula are we supposed to use for this question from formula number 1 and formula number 2? Which one is appropriate to solve this question we have up there?
Formula number 1.
It's formula number 1 because for this formula r on this question we have r which is greater than 1. R in this case is 2, which is greater than 1. Therefore, we need to use the first formula. So then we wrap this second formula we have. So we're going to use that formula. Now we want to calculate for n number of weeks in which this person is going to reach an aim of 200. Therefore, Sn in that case must be 200 equal to the first term is given as 1, and then the r is given as 2 to the power of n minus 1, all divided by 2 minus 1. So you simplify, you're going to obtain 2 to the power of n minus 1 equal to 200. You take 1 to this side, you're going to have 2 to the power n equal to 201. So now our task is to make this n the subject of the formula. Can any one of you tell me how we are going to make this n the subject of the formula if we have 2 to the power n equal to 201? How are we going to make this n the subject of the formula? What are we going to use to make n the subject of the formula? We're going to use logarithm. So we're going to have n, which is equal to log, and then base, in this case, is base 2. And then the index is 101. Can you put this into a calculator and tell me the value you obtain? What is log of 201 base 2?
7.65.
0.65.
No,
7.65.
0.65, of which you are allowed to round it off. You are going to obtain 8. Né? So if after 8 weeks, wherein this person will reach this amount of 200. So by that you have answered the question. You will even be able to get the correct answer if you do about 7 times here, because they're not many. Let's do 7 times and see if we're gonna get to 200. This is term 1, 2, 3, 4, 5. And then term after 16 is what? Is 32, right? And then term after 32 is 64. Is that so?
Yes.
Okay, then now let's see how many terms we have. 1, 2, 3, 4, 5, 6, 7. We also need to do the last term here, of which is 64 plus 64 is 1 what?
128.
128.
128.
Yes. Can you add the 7 terms and tell me what you obtain? Is 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64. What do you get when you add up to term number 7?
127.
So it's 127 plus 128, which will give you the amount of 200. So that value, you will be able to reach somewhere in between 128 and 64, somewhere in between. That's why we have 7 points in that case. It's not exactly at 8, but at 7.65. So you will be able to reach the value of 100. Okay. Are we all clear on the first question?
Yes.
Okay, let's go to the second question, which say, how much will he have saved by the time he is no longer able to afford the weekly payment? So it's question number 2, which in this case is 3.2. Okay, so already we have answered this question vice versa, but let me do it for you so that you can see how we can answer it properly. So we need to know how many will he be able to save until this person is no longer able to afford, to invest. So this person will no longer be able to afford to invest if the amount is what? It's more than his earning. Because you can see he's earning 200. So if that amount is more than 200, he will no longer be able to afford because it will be more than the amount he's earning. Are we all together on that?
Yes.
Yes, he will no longer be able to afford to save if the amount is more than the 200 we have up there. Okay, so now let's check from this. When exactly will this person will no longer be able to afford? You will no longer be able to afford after T8, because after T8 we are going to have 128 plus 128, which is what? You can do that with calculations for me. What is 128 plus 128?
256.
Yes, 256. So you can see this amount of 256 is now greater than the amount he is able to save. So it's term number what? This is term number 9. I think so. 1, 2, 3, 4, 5, 6, 7, 8. That is term number 9. So we will no longer be able to save from term number 9. Therefore, our n in this case must be 8. So now we are going to use the same formula of Sn, which is equal to A into R to the power of n minus 1, all divided by R minus 1. So we use S8 in this case. Let me check either S8 or S9 because we need to be specific between the value we're supposed to use. So we'll no longer be able to afford from N9 in this case. So at 8, N8 will be able to afford, but at A9 we'll no longer be able to afford. Then we read the question again. It says, how much will he have saved by the time he is no longer able to afford the weekly? Okay, so it's S9. So it's S sub 9 equal to, then the first term on that sequence we have here, it's having a first term of 1 into the R is 2, and then the N is 9 minus 1, all divided by 2 minus 1, of which you get the value of what when you punch this into your calculator. What is 2 to the power 9 minus 1 divided by 1, which is the same as 2 to the power 9 minus 1?
511.
511. Oh, this is the amount. Okay.
Yes.
No, it's fine. Let's go to the next question, which is our third question, which say, if he had been able to afford the payment, how long would it have it's not this. Okay, taken him to save 131.71 cents. So how long is it going to take him to save money to buy this car? So let's check. Again, we're going to use the same formula here. So, but we are given the SN, the sum of the amount you will be saving to buy the car. So we're going to have SN given by 13101. We want to calculate for N. So the first term is 1, and then the R is 2 to the power N is the one we're looking for, divided by 2 minus 1. Therefore, we're going to have 2 to the power of N minus 1 equal to 131,071. Take this to the side, going to be 2 to the power N equal to 131,072. Again, we have to use logarithm to deal with this kind of questions. There's no any other way besides using logarithm to deal with these kind of expressions. So we're going to have N equal to log of the index. Index is what you are given on the right hand side, which in this case is 131,072, and the base of which you're supposed to write down there. Can you type this into your calculator and tell me the value you obtain for log of 131,072 base 2?
17.
17, and that is the answer. This person will be able to save for 17 weeks. If we are following this pattern here, we'll be able to save for 17 weeks in order for him to afford to buy that car. But we know it's not going to be possible because his earning is 200. Therefore, when it reaches 200, he's no longer going to afford. So it's an imaginary or it's an assumption of which we are making that will be able to afford after 17 weeks if he's affording to save according to this plan that we have. Ask me any question with regards to question number 3 before we go to question number 4. You can ask me any question before we go to question number 4. So question number 4, it says show that 0.17 is equal to 17 over 99. Can anyone of you tell me what does this dot stands for? The one that is on top of 1 and on top of 7. What does that dot on top stands for?
Recurring.
Yes, this is recurring. It means these numbers they are repeating. Yeah? So now what you're supposed to do here is to let certain variable, which in this case we're using x, to be equal to that value which is recurring, of which you can write it in full. So let's write this in full. We're going to have 17, 17, 17, 17, 17, 17, up to so on. We don't know how many 17s we're going to have in this case because they are recurring. They're just repeating throughout. Okay, then now you can see this value is above 10. Therefore, you will need to multiply equation. We can name this equation number 1. You multiply equation number 1 by 100. If it was less than if it was less than 10, we're going to multiply by 10. But now it's more than 10, you multiply by 100. If it was more than 100, we're going to multiply by 1,000. So, or maybe in simple terms, you check the number which are repeating in this case. There are 2 numbers, therefore you need to multiply by 100. If it was just 1 number which was repeating, you're going to multiply by 10. If it's 3 numbers, you multiply by 1,000. Are we all together on that one?
Yes.
In this one, because the 2 numbers are repeating, you multiply by 100. So it's going to be 100x equal to, can you multiply this by 100 and tell me the answer you obtain? Multiply 100 with this 0.17 multiplied by 100. What do you get when you multiply this by 100?
17,17.
Yes.
17.
Yes. You get 17, right?
Yes.
Yeah, you must get 17 when you multiply this by 100. So that will be your equation number 2, of which after obtaining equation number 2, you then subtract equation number 2 with equation number 1. So equation number 2 minus equation number 1 is going to be 100x minus x, which will be 99x, equal to 17 minus 0.171717. What do you get? What do you get when you put that into your calculator?
16,82.
Let's round it off. It's going to be 17, right?
Yes.
You divide both sides by 99, so that that cancels. You have x, which is equal to 17 over 99. But we know x is 0.117 with recurrence, so it's 17 over 99. So we have proved what we are looking for out there. So are we clear with that question we have there?
Sir, I have a question.
Yes, you can ask.
Okay, can you please repeat the statement where you said if the number was less than 10, we're supposed to multiply it by 10?
Yeah, exactly. Let me repeat that. In simple terms, I'm saying if we had something like 0.7 with a recurrence on top, because it's one number which is repeating, we will have to multiply this by what? By 10. Here, how many recurrence do we have? There are 2, né? So if there are 2, we have to multiply by 100. If we had 3 of them, for example, we have 0.17 and maybe another number, let's say 3. 3 numbers are repeating there. Therefore, in that situation, we have to multiply by what? We have to multiply by 1,000. Is it clear now?
Yes.
Yeah. So you are guided by the numbers which are repeating. So the numbers which are repeating, they are the ones which guide you of which value you need to use to multiply. Because, for example, if you multiply by 10 instead of 100, you will see that here you are going to have a number which is not in terms of, you are going to have a number which is in terms of decimals, of which we want to avoid that. We want to avoid having number with decimals. Therefore, if you multiply by 10 instead of 100, you will still be having a number with decimals. So to avoid that, you multiply by 100. And then that's when you will get a number without a decimal. Can we go to Euclidean geometry?
Yes.
Okay, let me wrap off what we have on the board now. Okay, with Euclidean geometry, we're gonna start with question number. What is this question number? It's question number 4. Wherein we are given BD, which is a tangent, and AC, which is a diameter. I believe you have the question. I don't know if, because I know if I try to write it on the board, I'm not going to get the correct diagram. But let me just try and see what I get. Okay, we are given this information. So the first question, which is question number A, requires us to prove that ABC, this is a triangle ABC, similar to triangle BDC. And then this question number Roman figure 2, this is Roman figure 1. It requires us to prove that BC squared is equal to AC multiplied by CD. This is what we are required to prove. So now, before you do these questions, remember about the theorems first. And if it's possible, I hope you are hearing me, all of you. If it is possible, in your bedroom, go and photocopy the theorems and put them on the wall so that you remember all of them, because these questions require you to know the theorems. 12 from grade 11 and 6 from grade 12. In total, there are 18. There are too many. So it could be difficult for you to memorize all of them. So just go and put them on the wall, or maybe you put them on the file together with their proofs, because they have proofs. So once you have the proofs and you know the theorems by heart, no question can be difficult for you under this Euclidean geometry. It's one of the simplest chapters, of which you must get total, all of you. So now let's do it together and see how we go about it. So the first question requires us to prove that triangle ABC is similar to triangle BDC. So the question is, how are we supposed to prove that? There are certain conditions of which we're supposed to meet about a triangle, the two triangles which are similar. These are the conditions. I haven't taught you about this before because we are not yet done with a chapter for Euclidean geometry. I'm just answering this question because one of you sent me on WhatsApp. So I must answer it because you might have, your teacher might have taught you this already. So let me explain the conditions that you're supposed to meet in order to have two triangles which are similar. Now, the first condition is that two sides must be, let me say, three sides must be similar. So if this side is the same as this side is the same as that, this side is the same as that, therefore the two triangles are similar. That's the first condition. The second condition is that two sides must be similar and one angle. And then the other one, SAA, so it's one side and two angles. And then the other one is all angles that must be similar in this case. So these are the conditions which we must meet at all times to justify the similarity. Are we all together?
Yes.
Yes, these are the conditions we're supposed to meet. Now let's check which condition are we going to meet with this information that is given. Let's check on the diagram we are given there. Here we have a tangent. We have a diameter. So diameter is a line which passes through the center of the circle. Therefore, there is a theorem which talks about the angle which is subtended by the diameter. What is the size of the angle which is subtended by the diameter? The one at the circumference.
Repeat that again.
What is the angle subtended by the diameter at the circumference? There's a theorem which talks about that. We covered it yesterday. On Tuesday. What is the
90?
It's 90 degrees, yes. And the reason for this to be 90 is because it's subtended by the diameter. Are we all together on that one?
Yes.
Okay, and then from there, we have another theorem here. I haven't taught you that theorem. It's an important theorem which talks about the relationship between a tangent and a triangle inside the circle. What is the relationship between B3 and A?
Isn't it equal? They're equal.
And what's the reason for these two angles to be equal?
Tan chord.
Is the tan chord theorem, of which you must be able to prove that theorem, all of you. Is a very important theorem which you must take note of. Okay, and then already we identified that this angle C1 is equal to 90. So if C1 is equal to 90, what will be the angle C2?
90.
why C2 is equal to 90?
Angles on a straight line.
Very true. Those are just what we're supposed to do under this question. So we have identified that this angle here is the same as that angle. And again, we have identified that this angle is the same as that angle. So by default, this angle must be the same as that angle. Therefore, the third condition applies in this case. All the angles inside this triangle, the triangle ABC and the triangle BDC, they are similar because they satisfy this condition that all angles in these two triangles are similar. So let's write that. Already we have an answer, but now let's put it into context. So now we start with the first one, which is about this angle there. So we say C1 is equal to 90 degrees. What is the reason we gave for C1 to be equal to 90 degrees?
A diameter subtends an 90-degree angle.
Sorry, I did not hear you clearly.
A diameter subtends an angle which is equal to 90.
Definitely, diameter subtends. Or let me say subtended by a diameter. That is the reason for that to be equal to 90. And again, C2 in this case will be equal to 90 degrees. What did we say is the reason for C2 to be equal to 90 degrees?
Angles on a straight line.
Yes, very true. That is the reason. And again, we talked about the relationship between B3 and A. We said B3 is equal to A. Why are these equal?
Turn chord theorem.
Is the term chord. So now, by default, if two angles between the triangles are the same, therefore by default, the last angle must be the same. So B2 must be the same as D. Why? Because these are the angles on a triangle. So these are angles on a triangle. That's why this must be equal to that. Because this, we are talking about the angles inside the triangle. So, and I've told you that this, it answers the question that we have up there. So triangle ABC will be similar to triangle BDC. Why? Because this satisfies the condition for what? For similarity. Are we all clear on the first question there?
Yes. Yes.
Okay, let's go to the second question.
Now wait.
Yes.
On that, the fourth angle B2 equals to D.
Yes.
What if I give a reason that says the third angle of a triangle?
That is correct. It's the same.
Okay.
Yeah. Let's go to question number Roman figure 2, which talks about the proof again. But here we are proving that BC squared is equal to AC multiplied by the product of AC and CD. Okay, on that question, you must use the conditions for the similarity again. Let me give an example. If we have two triangles, so let's say we have triangle A, B, C, and triangle D, C, D, E, F. So if we are told that these two triangles are similar, therefore the ratio of their sides are equal. For example, if we say AC, in this, if they are similar, therefore AC divided by DF will be the same as to say BC divided by EF. That only applies when the two triangles are what? Are similar. Are we together?
Yes.
Yes, this applies when two triangles are similar. So now, is the same thing we're going to apply on this question. So now let's apply that similarity on this question, because already we know that this triangle is similar to that triangle. So we're going to have BC divided by. Then now we check the side that we're supposed to divide by in this case. So let's talk about BC divided by CD, this side that we have. CD, which will be the same as the other side there. So the other side, we're going to have AC for this triangle divided by this side BC. So now, where are we getting this information? We are getting this from a triangle ABC, which is similar to triangle BDC. That's why we are given that. So this is equal to that. Why? Because these two triangles are similar to each other. Are we all together?
Yes.
Okay, and then from there we cross multiply. We're going to have BC squared, which is equal to AC multiplied by CD. And we would have answered the question by doing so. Any question with regard to that which we have covered just now?
No.
Can we go to question 5? Oh, no. Before question 5, we still have question B, né? But question B is just the continuation of what we have up there. So we are told that AC is equal to 3 and CB is equal to 4. So we need to substitute this back to this formula that we have there and make, we are looking for the value of DC and make this the separate formula. So we're going to have DC equal to BC squared all divided by AC. BC in this case is 4 squared all divided by AC is given as 3. Therefore, it's 16 divided by 3. That is the answer we're looking for. For question number B, we say if AC is equal to 3 and CB is equal to 4, calculate DC. You use this formula you obtained from previous question to calculate for DC, then you get the answer. Are we all together?
Yes.
Okay, then now let's go to question number 5. So, but this meeting is going to end in 1 minute time. So when it ends, make sure you log in again using the same link.
Okay.
Yeah. So I'm wrapping off what we have on the board, and then we do question number 5.